Today on dotnet, we're going to be learning three things. F#, WebAssembly with Bolero. Yeah. Welcome to another episode of the On.net show. Today we've got Philip, Mr. F#. He's going to talk to us about the combination of F#, WebAssembly, and I guess the browser.
Yeah.
Yeah.
And some VS Code.
Oh, and some VS Code.
A little bit.
Okay.
More of just using it though. I'm
Okay.
not really gonna
talk
about too much what it says.
2 or 3 people watching the show who don't know who you are, how about you introduce yourself?
Okay. My name's Philip Carter. I work on F#, kind of all things like compiler, language, tooling, documentation, things like that.
Okay. Yeah. And you're a Microsoft employee, and
still am.
Yeah, still am. As of a few minutes ago. Okay. Awesome. So what are you going to show us today?
I'm going to talk about F# and WebAssembly, as you just mentioned.
Yeah, the story's staying consistent.
So WebAssembly, it's kind of this cool thing, I guess. But I think I want to back up a little bit before diving into the F# stuff, because some people may not necessarily be 100% clear on what WebAssembly actually is. They may know about a thing called Blazor. And that it uses WebAssembly, and there's kind of this stuff going on there. There's some efforts going on here to sort of get C# into the browser with WebAssembly. But there's kind of questions of, okay, like what actually is that though? What's going on? And so it's sort of, I guess it kind of depends on who you talk to, because there's kind of this promise of WebAssembly as being a like a replacement of JavaScript. Of all the JavaScript ecosystem, great language, maybe not so great. What if we could put another one in there? And there's been a lot of different efforts to like transpile the JavaScript, and to varying degrees of success. And some people trying to take JavaScript and make it better, like with TypeScript. But WebAssembly is actually sort of like I like to think of it as like a compatible alternative to like JavaScript. Like it's not intended necessarily to wholesale replace everything JavaScript related. Like that would actually be kind of crazy.
I don't think that's what it's
about. But it is
think of it as an alternative.
Yeah, it's sort of an alternative, but you can incorporate it with your other parts of your JavaScript application, and you want things to sort of live together rather than sort of create this own world for yourself where you can't talk to this massive, incredible ecosystem that can work in the browser today. And so it is fundamentally like a different runtime, and most browsers pretty much support it at this point and support it pretty well. And so there is C# support for it through Blazor, which we have some people working on.
Yep.
But there's also F# support, actually, that's built by the community, which is really, really cool.
Yeah, so how about I give my thoughts on, because I have some familiar with this topic as well. So one, some people call it WASM, so that's its short form. Another thing is that there was this project called Asm.js. So that was really the precursor to WASM. So if you ever see that, that's basically v.5 or something like that. I think of it like we have all these things, we sometimes talk about Linux, and we talk about like x64 and ARM32 and ARM64. I think of WASM as a single chip and a single operating system. Like, we'll talk about Linux running on x64 and Windows running on x64. WASM is just this one thing. It's this singular kind of character, and it's both a chip and an operating system merged together, and it's always the same everywhere. So there is no like Linux version of WebAssembly and Windows version of WebAssembly. It's just one thing. It's effectively a 32-bit chip, so it's 32-bit everywhere. And it's really cool because you compile this code, and it can run in your browser on this laptop. It can run on your phone, iOS and Android, and no one has to be the wiser. They also don't. It doesn't matter which language you started with.
No, absolutely not.
You can start with C, C#, F#, and I'm Go.
There's
anything.
even a JavaScript
I
to
was-
WASM
I was-
project,
I
which
was
is
thinking-
kind of weird, but it's a thing.
Yeah.
If you can do it, you might as well, right?
Yeah, for sure.
Yeah,
Cool.
so with that in mind, there's kind of, one of the things that Blazor does is it builds on top of that foundation. And it sort of, gives you kind of the traditional, like, hey, I have a framework with which I can start building things with. And, I don't have to necessarily know, what the IL of WASM is and how everything that I do translates to that action.
The WASM of WASM.
The WASM of WASM, yeah. You can just sort of have an opinionated way to build apps. And so Blazor does that for C#. And so Bolero is something that you can do that with in F#. And it actually uses some of the components of Blazor under the covers. It doesn't have it's not the same framework necessarily, but it's a lot of the same moving pieces, just sort of, going in an F# direction.
Right, so it's, if you think about it super simply, you could say it's Blazor for F#-ish.
Yeah, in a way.
Okay.
And so, they got this wonderful site. If you go to fsbolero.io.
Oh, okay, let's check it out.
Bolero, F# and WebAssembly. You can develop SPAs with the full power of F# and .NET. They have this cool button, which I'm going to click soon. But what's great is there's a super easy getting started experience. You just need .NET Core. And so after that, you just install some custom templates. You can create a new app, and you can run it. And then when you run it, they have a little video kind of showing that sort of thing. It's very simple. So I already actually have that on my machine.
Yeah, and I assume you can do this on Windows, Mac, or Linux.
Yeah. I have this on a Mac right now. I could, if I was running Windows, it'd work the same. If I had Ubuntu or something, it'd be fine. And there's definitely a lot here. Like it is about fundamentally writing F# code. Like you don't have to write both F# and JavaScript for the web app. You don't have to write F# and C#. You can just do F#. And it uses a particular way of doing things that's called model view update, which if you've heard of model view controller, it's just one, instead of C, it's the U update. And it's sort of oriented around this notion of you create types that represent sort of the domain of the UI. And say, okay, well, this page could have this number of things that you could click on. When you click on this thing, there's sort of an action that can happen, and you sort of want to update the UI based off of that action that was performed. And it's sort of like a very top-down sort of like, any action kind of, you can conceptually think kind of goes through the top of the page, and changes sort of percolate through the page as it re-renders based off of what you're actually doing. It's very similar, like this is what React was built on top of, like this sort of idea. The Elm language actually pioneered this thing called the model view update thing. And so there's this library called Elmish for F# that takes that same concept and makes it available in F#. It is agnostic of UI technology, so you can use it with F# transpiling to JavaScript, or you can use it F# on top of WebAssembly. And so that's what they do here. And then they add a bunch of other little goodies like HTML templating and some opinionated ways to do, communicate with the server with your UI and things like that. So there's a whole lot in this package that you can do, which is pretty great. So although it's experimental in the sense of, it's preview and it's on top of a preview with, Blazor being a preview and WebAssembly perhaps also being preview.
Right.
Like, I think it does actually a really good job of showing you, like, what a really true complete picture for building real apps could actually look like. And speaking of real apps, why not be as real as the actual F# compiler itself?
Right. There must be a lot of code to run through with that thing.
There is a lot of code in the F# compiler. And so what they actually have here is you go to tryfsharp.bolero.io. If you click this button, it takes you there. There's a couple of different samples that this is actually executing F# code in the browser. And it does it by taking a thing that we call the F# compiler service, which is, so the way the F# compiler is factored is there's a thing called the compiler library. And that's what does all the actual work. And then we have, like a head on top of that library called FSC. And FSC calls into, fsharp.compiler. It's called F# compiler private. It's the compiler library. And that's what does all the work. Well, that stuff it doesn't care if it's running on Windows or Mac or anything like that. It's just a library. It's .NET standard based. So they just take that and they say, oh, well, we're just going to make this run on WASM. And so what I'll show here.
Right, and this is similar to how WASM works. It has a similar model.
Yeah, absolutely. So
I was
got
going to ask you to do this because
Yeah.
I don't believe anything you say.
yeah.
So,
So I got my
I think we want network.
yeah, there we go, network. Okay, so I got 0 right here. So I'm going to go ahead and execute some code here. Let's call Fibonacci of 5. So one thing that you noticed, actually, I deleted something. You notice I got an error here. The type,
quite quickly.
yeah, the type int to int, which is a function, is not compatible with any of the types byte, blah, 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 arising from printf style format string. This is basically saying I specified %i, which means int, but I simply passed it a function type. I didn't pass it, the result of a function call.
Yep.
And so the compiler immediately complained about it. If you'll notice over here, though, there's nothing in the network at all.
Right.
So I can put that back in. It's happy. I can run it. It actually compiles, does that. I can do that. Oops, sorry.
Right. We could be doing all of this in a Faraday cage
Right.
right now, and it would
Absolutely.
and it would be the same.
There's none of this. The only time you'll notice the network here is when we change we change source files.
Okay, so all we did is we did a fetch
Right.
across the network, literally to get the text
Yeah.
of this program,
Mm-hmm.
which is, yeah, in no way breaking the WebAssembly model.
Right. So I just had a thing where I can have it say hello rich to you, and sure enough, it compiles and runs hello world, hello rich.
And
So
still no network.
still no network. And well, now we'll hit the network even more. But this is we're going to use no network to make a network call.
Right.
And so what this does is this actually hosts a JSON type provider, which is a feature in F# where you can basically point an arbitrary data source at a component that can then hook into the F# compiler and give types based off of that. So in this case, it just has some JSON and it parses it. And you'll notice there's this repo.name thing here. That name property, like that's an actual property. Whoops, that was generated by the F# compiler running in WASM. And so again, there's some network calls now, but that's because we actually went to a real URL here.
Right, it's line 10. Oh, okay.
Right,
Yeah,
and so this is just a JSON blob
yeah,
at
which
this
also
point, right?
makes total sense.
Right, and so, but if you go, there's a name property, and this, for repo.name, that name actually corresponds to this name property right here. And so what's going on is in WASM world, it went and it made a web request. It got the JSON document, and then it parsed it, and it was able to then call into the F# compiler that's running in WASM and interpret that JSON and say, oh, here are these properties, like things that are called name, and actually print it out. And so every single repository in that the GitHub API gave us here, these are their names, and it just kind of prints them out in a bullet-pointed list. So
Right.
This is pretty cool because I feel like if you're to the point where you can host something like the F# compiler in WASM, you can host a lot of stuff.
Right, exactly.
Yeah. So there's
So one thing to talk about is my thinking would be that so let's start from the beginning. So the runtime, the mono runtime, that's what we use here. It was compiled to WebAssembly because it's native code. But then basically everything on top of it, I think, is actually interpreted. So
yeah.
like basically what we do is we take in that text, which is the textual program, run it through the F# compiler. The F# compiler has to be interpreted, and then all of its like BCL dependencies underneath it are also interpreted.
Yeah.
So the only thing that's actually WebAssembly is the runtime, and it's amazing. I'm actually shocked how fast this is.
Yeah, it's pretty slick, and and even though I said it's preview tech, I mean I think that goes to show that once we sort of determine that this kind of stuff is not really preview anymore, it's going to be in pretty good shape. We're not going to be kind of coming out the gates with this sort of thing that you can't feasibly build things with. And so so all this stuff is actually all open source. There's a repo called try F# on WASM. That's exactly what this is. And so there's a couple components of this. The main thing that we have here is in the client. They use, instead of the NuGet client, they use the packet client, but it uses the same stuff under the covers. One thing I want to call out is this is a list of their dependencies, and that's it. So there's Blazor build, Blazor CLI, because this is so that they can actually orchestrate stuff on the client, and then just the core Bolero, They have a fork of the compiler service that makes it available on WASM, and same thing with this F# data library. And that's it. That's all that this is actually using. Aside from that, this is just normal F# code, like this app.fs. Like I promise you, there's no like embedded stuff going on here. This is F# code, and this is they call into the compiler library. They have this thing called compiler. They represent okay, we have all these options that we accept some source text. We have to sort of.
Right.
There's this thing called the F# checker that's like a component in the compiler service. They have to do that so they can actually type check the code. And all of this just runs in WASM, which is pretty radical, I think.
So one question I have is, I know with the Blazor model, you basically can say, oh, I want to do the client-side WASM thing for the reasons why that's good. Or they have this alternate model, which is, I want to run on the server. I want my C# code to run on the server, and I'll use this SignalR pipeline for DOM updates. Does Bolero support both of those models, or is it basically WebAssembly only?
You can support both. And so there's some different ways that you can configure it. Like, they have this .NET new Bolero app, for example. That kind of gives you the whole package. If you, you can get a little fancier with configuring what you actually create. You can create something so it's client-side only if you'd like, but by default, this also includes like, the SignalR channel
so
stuff.
in that way, it's the same as Blazor.
Yeah, exactly. And I think that's sort of a goal here, is sort of saying, this is kind of where Blazor wants to go. We're going to sort of have that similar kind of model going on the F# side.
Makes sense.
And so I actually created one of those on my machine here. You'll notice there's two folders here. There's this myapp.client and myapp.server.
Oh, actually, before we leave Bolero, or maybe we can do this at the end, we should do some shout-outs to the people who actually worked on that.
Yeah, absolutely.
Okay,
I definitely plan on doing that.
Okay, just checking.
Yeah. This is not a thing that we created. This is an F# community thing, actually, a company called IntelliFactory that builds a lot of really cool F# stuff. Some of the folks working there are just absolutely incredible F# engineers. So that's why they were able to make this happen. And so I just want to show, like, the project file for the server side. This is just a single F# file here, running .NET Core 3.0. This file, this is all configuration. I don't want to call it nonsense, but stuff that you generally don't look at too much.
Boilerplate.
This boilerplate sets everything up. It needs to do this configure services thing, just like you would normally do in a Blazor app, and it kind of has a certain convention here. There's this iWeb host environment thing. This is where that sort of communication things come from, and there's this thing called a handler. We want to set up a handler for different stuff.
Yeah, we wouldn't exactly call this intellectual property.
Right. Yeah. So that's sort of, you would see a similar sort of thing on Blazor side, but in this case it's all in F#. And this is all still this is just .NET Core. So that's perhaps not as interesting here, but I think this is where it's more fun because this is a UI that's written in F#. So let me just actually run it first.
Right now we're running a web server.
Yeah, so I'm initiating the web server, and so what the web server is going to do is that's actually going to then host the app in the browser so you can interact with it. And when you're actually interacting with the app, that's not making any calls at that point, unless like you're doing something that requests like serving a new page or something.
Right.
Like
So
that.
so the main purpose for this web server is to serve up the WASM files and also just the ILDLLs.
Right. So you can see here, now we have this thing. Hey, welcome to Bolero. So this is just like the template that kind of shows you a couple of different features. It says this entire application is driven in Elnish. So if you're kind of curious, okay, where does this come from? Where does this come from? What's that all about?
Yep.
That is driven by a couple different stuff. Like there's some standard HTML stuff here, but it includes a templating system. So you got kind of this $ sort of thing. These are sort of little holes that you put in the HTML.
I see. So this is similar to the Razor files. Ish.
Yes. But then you sort of put these holes in there in a way. At least that's the way I like to think of it. Is sort of saying, oh, this is going to be what's filled in by the F# code.
So one question I have on that, and maybe the designers would have to answer this, but like the ASP.NET team with Blazor and stuff that came before it, they did the like CSHTML extension, and now I think what is it now? Just
.razor.
.razor.
Yeah,
okay.
.razor.
Yeah. And so they're basically saying this is very similar to HTML, but it is indeed a different format because it's got all these it's the templating engine thing.
Yeah.
Do you know why the folks here just decided to go, oh, it's HTML, it's all good?
I think it's probably just a design choice, I think, at that point. Getting the F# stuff to work with the Razor files can actually be quite a challenge.
Oh, yeah, I didn't mean necessarily use .razor.
Oh, right.
Like
Yeah.
use,
I think,
FS Razor or
yeah,
something.
they'd probably be able to answer that. My best guess is most web developers or people who do web development, at least to some degree, are familiar with .html.
Sure.
And as it turns out, you can actually just put stuff like that in HTML anyways.
Yeah, this reminds me of Knockout,
Yeah.
which I used before.
And so the folks who built this have been doing F# with web for quite a long time. So that's definitely totally up their alley.
Yeah,
there.
definitely not a critique, just a question.
So we have this file here called main.fs. And so F# files you typically want to read top to bottom because usually the way that things are architected is there's the stuff at the very top and then stuff below it typically depends on that and so on. So at the very top we have this notion of a page, or at least what we're saying what a page is for our app. And a page can either be the home, the counter, or the data. And that actually corresponds right here, home, counter, and this thing called download data. If you navigate on those, okay, those are those different pages. This is a special convention that they have, this endpoint routing. This is just sort of a very convenient way to sort of say you can use an F# union type to say, okay, these are all of my pages. These are their names that I'm going to refer to them by in my F# code. And this is the endpoint that I'm going to associate with it when you actually navigate via URL.
Right. So I would assume this isn't literally ASP.NET Core endpoint routing. It's just inspired.
Yes. Yeah. Exactly.
Yeah.
It's just a little attribute you throw on there, and that's
Makes
just
total
kind of
sense.
how it does. And so back to that MVU stuff. Here we're defining a model for this whole thing for actually all 3 pages. So we say, okay, well the model, as we're calling it, has a page, right? So a model, so you can sort of think, that what the user's actually interacting with at this point. They're interacting with a page. There's this thing called counter, books, error, username, password, signed in as, sign in fails. This, say I sign out here, I'll go admin, and I think the default is to just password is the password. And then you can see like there's these books, you can reload.
I've heard of some of those.
Right, and so that's sort of all of this data is being represented with an F# record type. Sort of just a conglomerate of like all of the, your conceptual model for how the page works. And then book is sort of like a special one. A book has a title, an author, a published date, an ISBN, and all of that information is also listed on the page in the table form here. So when you have a model, you want to initialize. You need an initial state, right? So for example, there's no username, there's no password, you're not signed in as anything. You didn't fail to sign in because you didn't even do it. There's no books. There's no error. The counter, on this little counter page here is 0 because that's just the initial state. That's kind of how you sort of define it. You define your model. You define an initial state for the model, and then you get into some fancier stuff. I'm actually just going to collapse a few of these things because I want to get to this stuff called message. This is where you start getting into the update notion.
Okay.
Of you're going to update the UI. Well, what updates the UI? Well. They use sort of this UI message sort of paradigm where you say, okay, an action performed on the page has like a message associated with it. So in this case, the set page message sets which page we're going to be on. And you're going to say, okay, what page are we setting it on? Are we incrementing or are we decrementing? Are we setting the counter of something? There's this increment, decrement sort of stuff. Are we getting books? Did we get some books? If we got the books, there's an array of these book types that allows us to actually display stuff. So there's a whole bunch of different messages. When you build one of these apps, you can break these up into different like message families.
Okay,
and things like
I was
that.
going to ask that next because in this page, it's not a particular problem to group all these together. But you can imagine with a large site, you wouldn't want to mix all these things together. And in fact, in some cases, you might want to reuse the same name, but do something slightly different.
Absolutely. Say you had an entire page of counters, for example. You could have different like counter messages, things like that. That could all be done there. I want to walk through very briefly what this counter thing does, actually.
As an example.
Because kind of at the very bottom, there's a lot to set up here. But it eventually it initializes the actual application. It does this program.mk program or make program. Passing in an initial model. Some initial message state, like all the initial state there, and then it's sort of set up where you define all of your functionality for how your model that represents the UI. You define your messages for how that UI can change, and then you define an update function that actually performs the update itself, that changes the current model, right? There's this function called update. It in this case takes in a thing called remote book service. We're not really using that in this particular part of the demo, but it takes in a message and it takes in what the current model is, and it produces a new message, a tuple of new message and a command, which is like what was the actual command that was sent in this case. What was the message that was sent here? So this model is the thing that actually gets updated. So as I highlighted it here, you'll notice there's model after I increment, it's model with counter equals model.counter plus 1. Well, that corresponds to the increment message. So when I hit this button here, that actually sends an increment message to this update function. And it says, okay, well, we received an increment message, so what do we do? Oh, well, in this case, we take the current model that we're working with, and we create a new one that has its counter, plus 1. And so you can define this kind of any way you want, but now you define sort of your whole, at least that part of the UI that you want to have changed. You have that represented as a single F# type, and you just construct a new one with different data that corresponds to what you want based off of the action that was taken. And it's pretty straightforward, and it's also a very F#y sort of thing, right? It's all about just functions and data being passed to functions. And
yeah, makes sense. It kind of
cool.
reminds me of. It seems almost like the midpoint between MVVM and PubSub.
Mm-hmm.
I don't know if that's. I'm sure people are screaming at this point, but
I can see this sort of takes some of the MVVM stuff that people kind of like about, I have this very deliberate modeling of what my UI actually is. And the PubSub thing of like, that actually totally makes sense, I think, where I set up, okay, this is the initial state of everything, and now I'm sort of listening to all these different kinds of changes, and depending on those changes that I get, here's how I'm going to change, the data that's in the model there. And that is basically what MVU is. And so this is, just sort of like a little, it's a demonstrative thing. It's not like a real app, but you can imagine, real apps can have many update functions for different pages. They can have different, componentized stuff there, and so. It's quite nice, and what's great is it's all F#. There's no, we're not hitting the network for this sort of thing.
Well, we could do view source again.
Yeah, we'll go view.
Or inspect.
Inspect, yeah.
Well, inspect isn't super useful because there's clearly DOM updates going on.
Sources, okay, there we go.
Yeah, okay, whatever. Okay, so how about we should probably close up. So
I haven't used the dev tools in this before, so
yes. Let's remind people where they can find this stuff so they can do it at home, and then we should finish any
absolutely
kudos you want to do to the Bolero folks.
So if you go fsbolero.io, which we'll probably put in the show notes here, they have a very clear getting started thing. The video that they play, you can watch that. It's like 30 seconds long. It just shows it all running. You click the Learn More button. There's a whole lot more that you can learn about. There's different, what's this routing thing all about? How do you do remoting? How do you do this? How do you do that? It's all open source as well. So if you're the kind of person who wants to kind of hack on it a little bit and improve it, they take contributions, which is pretty great. And I'll actually navigate to that GitHub page so you can see who these folks are. So the FS Bolero organization has a couple people in it here.
Oh, that's great.
These are the folks that kind of make it all happen. Adam in particular, he's been in a big part of the F# community for a very, very long time. He's kind of, I think he's like the owner of the company that
could
they
be.
work for. And so they build all this stuff, which is pretty great. They accept contributions. And they have quite a few things, like, there's Bolero, the core library itself. There's this hot reload thing where you can, with kind of the client-side stuff, you can just update a very tiny component, and only that will be re-rendered. You don't have to refresh the page. The actual templates for getting started, the website, the actual try F# on WASM. They have all their forks for different things that they actually utilize. These people are fantastic. I definitely recommend.
It looks pretty legit to me.
Yeah, I definitely recommend interacting with them if anybody's
help
interested in this sort of
or want to help them.
And definitely get started with it. I mean, I honestly think the WASM stuff, there's the promise of WebAssembly is or rather the thing that people want out of WebAssembly is extremely compelling. And this and Blazor and other efforts kind of show that we can actually get there.
Yeah. I mean, this stuff is all about to ship, so not in the foreseeable future. So for sure. Okay, well, this is great. Thanks for being on the show again, Philip.
Absolutely.
This F# stuff looks amazing. I mean, I think for the F# community, they must be just eating this up.
I mean, the F# community is always doing amazing things.
Yeah,
like this,
for sure. You're telling us that basically every day.
Yeah.
Whether we want to hear it or not. Okay, this has been another episode of On .NET, and we've learned about F# and WebAssembly with Bolero. Thanks for watching.